All right, we're group 11, and this is our Levitator project setup. We decided to use an Arduino Uno R4. We're powering our system with 12 volts, and we're using the Hall effect sensor, which is on the roof here of our apparatus, using a MOSFET as a switch, basically, and also Dr. Heidecker gave us some feedback to add a diode just to prevent any damage to any components. So basically, this is where we're at with our system currently. Basically, the magnet tries to stabilize at the set point, but there's an exponential relationship with the force because there's an internal magnet within our pre-bought electromagnet. And as you can see, it's kind of shaking and oscillating at its set point, but we can't account for the internal magnet. So even when we cut the current completely off, there's still a response. So I'm going to let Daniel and Braden talk more about this issue that we ran into.
So like Chase said, this is kind of our biggest issue at the moment. So the problem is that because we bought a pre-made electromagnet, it's got a permanent magnet inside of it already, and so that always has a force acting upwards on the magnet, even when it's off, even when there's no current or anything running through it. And what we failed to model that pretty much. So obviously there's going to be another force when the magnet's on that's also pulling it up. So pretty much what we need to do now is we already have our kind of an idea of where our set point needs to be, and we need to be able to account for the force when the magnet is off and when it's on, be able to differentiate the two so that we can relate how much current needs to run through this magnet compared to obviously gravity, because gravity acts the same at all times. The magnetic force when the magnet is off also corrupts our Hall effect sensor values. So the Hall effect sensor is always has some sort of detection of there being a magnetic field there because there is a permanent magnet that still exists. So that's our issue.